So, I am not going to take you through the second half of this curriculum in under a minute, but I'll show you sort of what it is. Um, what we just described is a general artificial neural network. Um, there are specific kinds of neural networks that are better for specific kinds of activities. A convolutional neural network will do most of your image processing. Um, the problem with a regular neural network, every layer is connected to every other layer, which takes up more space and more connections than is necessarily necessary. It can't tell where anything is. Um, Whereas a convolutional neural network looks at sections of an image at a time. And then I show you here's a scrambled up image that you can only look at sections of at a time, but can you tell what this is an image of? What is this an image of? Someone can put it in the chat.
A cat.
It's a cat. Yeah. So what convolutional networks do is kind of this. They find particular parts of images that look to be eyes, nose, mouth, etc. And then if they're in the right locations, which in this case they're not, but if they're in the right locations, then it says, I see eyes, I see a nose, I see a mouth, this must be a face. I then go into videos about what each layer of a convolutional neural network is doing. Mostly it's the same thing that a filter does on your, if you have like a Snapchat, or not a Snapchat filter really. You know how you can take pictures and make them black and white, or take pictures and make them blurrier or sharper. Those are all filters. And what's going on in the filters is some matrix math. Matrix math is just math with numbers that is already in columns and rows. To give you an idea of how much I hand wave the math here, math is in columns and rows. The way convolutional neural networks work is they find matrices that they can put on the image to find specific lines, to find like, it looks like there is a circle here. And upon finding those filters, they put the filters together. And it's a lot like what we did for our activity. Convolutional neural networks work more like our activity than any other kind of neural network, because convolutional neural networks are looking at pieces of an image at a time. So there's a bunch of like playing with convolutional networks and seeing what each piece does. And then I introduce you to Noreen Mahmood, who works at a full body animation AI company, and also Yanisel Placentia Kalanya, who is a data science researcher who at one point worked on finding cancer through images. So that is more how neural networks work than convolutional neural networks in particular, since we didn't quite get to all of that. But so you have a sort of closer idea as to how the things that we've been talking about all week work. And now I am well over time. So thank you all very much.
Thank you, Sarah. That was really fun activity. I want to steal that and use that with my students this year. Yeah.
Definitely. There's a lot there. And of course, the more you got it, that's definitely more of a high school thing, not the elementary level kind of. Yeah, so for sure. All right. I do want to ask though, this is the version of that MNIST thing that I use with my students, and I like it. So let me draw something here, because it flattens out and you can kind of see the layers better. And I don't know if you folks did this when even in the layer, the one that Sarah showed us, but if you click on anything, it shows you, so at that particular node is the input layer, it's the 242nd pixel. That's the value that came in 1.17, and that's literally the calculation it does to plunk it back out as 1.17, so forth and so on. And then if you come up here, every single one of those pixels goes to up here, does that calculation, and there's that math thing, it's doing a tan H. Okay, and then you can finally see how it's deciding that it's a 3 Okay, because it was the max out of all of them. So I don't know. It's just a different version of what you were showing. So, and I guess I always save this link instead of the other one. So I forgot about the other one. But yours does put it in the matrix version, so you can see how it's looking at the edges and different parts of it. So that's pretty cool too.
Could you share that link as well, please?
Yes, I also, it is in the it's in the goal setting slides as well. Let me put this here. Okay. All right. So anyway, my hope is to, very quickly, to show you some of the cool things that we never even took a look at in machine learning for kids. Let me go ahead back. I'm going to start in the slides. So first of all, so in the introductory course, when we did machine learning for kids, we did that text-based thing, the happy versus sad, and how you could put it in a Scratch program. But we saw yesterday also that machine learning for kids, that you can do images. And when you do an image lesson or an image model in there, instead of putting in pictures, you can actually draw all of your data in. And this is actually, I got excited about this because earlier this week when we were doing that quick draw thing and we were talking about that some more, I'm like, hey, this is giving me ideas of using machine learning for kids, where if I put in all the ways I draw cats, or the kids around me draw cats versus the way the kids around me draw mice, and I could train a model, and then I could test it and see, if a new kid came in and drew something, would it be able to recognize whether they drew a cat or a mouse? So you could kind of tag this on with using that quick draw lesson in there. And then you can take your model and you can open up in the machine learning for kids Scratch version and make a program where you could use the costumes. You could, put some pictures on costumes, and you could, try to figure out what it is. My particular one didn't work that well, but I guess that's because I was using pictures, and I actually do have, let's see which one it is. Yep. Okay, so here if I click over here, started with a sprite, and then just put a bunch of different pictures, and you see how I made some of them drawings. Okay, so this was using that machine learning model. And then if I go back to the code, and I think I have to click on, yeah, I have to click on Scratch here, and it recognizes this is a cat, believe it or not. But you can see it's not very good because it says that this is also a cat. Yep, of course, that's a cat. It does recognize this one as a mouse. Okay, so I was able, do I have this up here? Sorry, I have so many things open, but I do want to show you. Here's my projects. Yeah, so here is my data. Here are I only made 6 of each, and that's what I trained and put into, so basically you're terrible at drawing mice. Yeah, thank you. Excuse me. All right, but, and then there was that other conversation we had about what if I wanted to show or demonstrate to the kids, like, I want to train you to learn something new. I'm going to make up a word, and I want to train what this means to me, what this word is to me. So, by the way, I now have 2 accounts in machine learning for kids. And I went in and I created this one, and I have this thing called a Who's It, and I have another thing called a What's It. Totally made up, right? And I decided that this is what Who's It's look like to me, and this is what What's It's look like to me. So I trained a model, and I went over and I put it into a Scratch program. And this one's different. So I also figured out, by looking at the worksheets that Machine Learning for Kids has done, is what you can do is you can come in here and you can make a sprite, and I guess I learned that you can make just the middle bigger. oops, bigger, bigger, bigger. But I don't know if you can see down here. I have scratched the cat, but I also have a sprite in here. And when I go to look at the costumes, I had originally started it as a blank, but here's what you do. This is the cool part. So you write the program, and then you have the kids come in and they go in, let's paint a new costume. Click on the brush, and I'm just going to draw something. So you draw, basically, yeah, I'm trying to make a stick figure. Okay, so I draw my new costume. It shows up, and then I go back to the code. And when I click on my drawing, which is probably actually not a good idea, because I found out if you click on the white part, it won't work. You have to actually click on where it exists. And no, it's not letting me do this. Okay. So what happened here is I am separated from, my model is broken because I made it yesterday in my other account and it's no longer linked up. So my apologies. So here are some of the things that don't work here. So you can't make a new one, but I'm wondering if I go back to my old costume, will it work with my old costume? Yeah. So it works with the old costumes that were in there, but it won't work with a new one. So that's something new I learned. But you can see it recognized that one as a what's it. If I go back and click on this person, come to the code and click on that, looks like a what's it. So it's actually not working that well. To me, that should become up a who's it, because it looks more like a person than a thing. Okay, so anyway, this is just ideas. This is just me playing around with this combination of being able to go in, create an image project, but choosing to draw instead of, can I draw another cat? I'm just going to make another thing with ears on it and a tail. Woo! Add it. Okay. And the neat thing is about this type of image project is because it's just line drawings, just black and white line drawings, it's actually a very quick model. It's not like loading up pictures or coming in from the webcam that would take a little bit longer. All right, so these work much quicker than a picture image model. So I thought this was super cool. And if you look in the document that I have linked, I have in here, these are the blocks that I'm using in that program in case you wanted to make it yourself. So here's the code for the blank sprite where you can go in, draw a new costume. And when the sprite is clicked, I would actually change that to maybe when you click on a certain letter or something like that might be better, you know? So it would go in, look at the costume, use the model that you trained, set a variable guess, and then my other sprite, which actually talks, has to get a broadcast message that is going to take that variable and just do something. Okay, so this is just a very basic program to just make that connection between what you can do in machine learning for kids and what you can do in the Scratch program. And then from here, what do you think could be a bigger project? Actually, I want to hear, does anybody have any ideas? Like, what would you be your next step to take with a class? Knowing that you can make a drawing in machine learning for kids, train a model, and then take it over to Scratch and have it recognize it.
What do you mean? Like, what kind of lesson could this be?
Yeah, like if you could say, here's how you do this. Now, what kind of program would you make from it?
Could this be like the start of animation or something? Perhaps. I mean, like maybe a conversation between the I don't know.
Well, it would, like animation as in you're drawing something and you want to label it so that now I know what you're drawing. A Pictionary. Yeah, isn't that the basis of Pictionary?
Yes.
Okay.
Yeah. Yeah. So I'm just, yeah.
Kind of what I was doing in my first lesson that I made on the first day with Quick Draw was to tie it to Pictionary.
Right, right.
And that's how you got that idea of drawing things that that are nonsense.
Right, right.
So that would work well.
Okay. And the other thing is you could probably, I mean, I only have in my model here, I only have 2 labels. But you could also connect this to the digits. You could come in here and make 10 labels, 0 through 9. And you could draw in, here's a whole bunch of ways to make a 0. Here's a whole bunch of ways to make a 1. And you could connect that to the lesson like Sarah was just showing us, where you're going to be training your own digit recognizing machine learning model and have it go in and then use it in the Scratch program to label your drawings, your numbers. So just, just wanted to, hope you guys were excited about this kind of cool thing.